Hi boys and girls, welcome to a new IB physics video. In this video, we'll talk about the circular motion questions in your textbook. Pay attention that the last question has some problem itself, and therefore please have a look of how I clarify the question before you start to do it. As usual, we'll go through the study guide from IBO for this chapter first. I won't read all these points for you, but I think mainly there are a few things you want to pay attention. So the first one, if you want to do well in this chapter, then you have to be very familiar with the free body diagram. So what it means is you have to know how to draw the forces and the direction very well. Say when you're at the top of the loop, you know that there will be normal force and also weight, or maybe sometimes like more like a horizontal circular motion like this. Then this tension, and about the trigonometry things. So these kind of forces that requires you to understand the situation very much, and therefore to set up the correct equation in that case. And secondly, of course, just like what we said about the angle here, so you have to be familiar with the trigonometry here. It's not very hard stuff, but you have to make it correctly and be careful on that. And for the equation, we will see from the data booklets, basically these are all you need, especially for the first two. Basically the third one is quite useless because you can just derive it as long as you got the second one. Then you know F equals ma, and just substitute the a inside and you will find the equation basically. Sometimes you will need, apart from these two equivalence to acceleration equation, you also can think about the omega as well, which means here. So therefore for A, it's not just these two, but you can also use, if you try to substitute what you have here, which would be omega r square over r, because you know, just substitute this one into this one, and therefore you have omega square times r 1 times. That's in your textbook you see this is also one kind of form of the equation. And also for the last one, you also see that the capital letter T means the period, and you know period is same as 1 over f, which is the frequency. And therefore you may also say acceleration sometimes when it's convenient to you, then you may say a is equals to 4 pi square r with the 1 over, sorry, not 1 over, but frequency square here. So there are basically four kinds of different versions. So one is this one, second one is this one, and also two other kind from the data booklet itself. So you should know how to make it clearly. So I think you should be able to do that by yourself as long as you got the linkage here. For the first one, it should not be very difficult. You just look around what equation you have. Since it asks you about calculate the angular speed and linear speed, so I think you have to be familiar with the term and the symbol itself. Angular speed means how much it changes in terms of the angle, so that will be omega. And linear speed is just a normal velocity that you have been using for a long time. So that's the equation that you need. And since you got the period, which is 1.24, you can substitute it and you find the answer. Remember that from the equation itself, you can already see that 2 pi is basically one circle, the circumference of the circle, and also t is the time, and therefore the units is radian per second in that case. So be careful about the unit itself. And also for linear velocity v here, then you'll be using this equation. Since you got omega, you just substitute, you find the answer. And linear speed, of course, is in meter per second. For b, that will be frequency, and since you got the period, then you just substitute and then you find the answer. And the unit for frequency is in hertz. Second question, again, is very simple. look at the question, it tells you the R and tells you that is 3.5 revolution per second. That means it is the frequency, and which means it is 3.5 hertz. That means it can complete 3.5 circles, revolution in 1 second. And therefore, if you want to calculate the centripetal acceleration A, then you can look at, like what I said, there are 4 kinds of version, right? 1, 2, 3, 4 kinds. And therefore, you look at that and try to see which one is the most convenient for you. Since you got frequency, you got R, then of course, the last one is the most convenient for you. Therefore, you go for the last one in that case. And therefore, substitute all the things, you find the answer, which for acceleration, for the unit, it will be meter per second square. For the third question, is actually quite inspiring question here. You may not really see that when you first try to see the question, but I will tell you why at last. So firstly, from the question, it tells you the radius and the linear speed. What you're gonna do is to calculate the magnitude and direction of the average acceleration during the quarter of revolution from A to B. So, like what I draw here, you can see the velocity for A and B, which is tangential to the point. So what you're gonna do is, since you want to find the average acceleration, and by definition, average acceleration means the change of velocity over time, and therefore you want to find the change of velocity first. And if you look at the picture again by vector, what you learned in the previous chapter, then you see for 4 and 4, and the difference of them will be the change of velocity. And therefore, you can calculate the change of velocity as using Pythagoras theorem, because they are in right angle here, so that you can use Pythagoras theorem, and you can find 5.6 this one for the change of velocity. And then you can find the change of time. That means how much time they spend to travel from A to B, which is a quarter of the circle, and therefore you just simply use your math to calculate it. And therefore, for the average acceleration, like what I said, the definition is change of velocity over change of time, and therefore is 7.2 meter per second squared. All right. For part B, it also asks you the acceleration, but the centripetal acceleration of the mass. Actually, at any point, it should be the same, since it's constant speed and constant radius. Therefore, you just simply look at what you have. Of course, you have 4 kinds of version of centripetal acceleration for calculation, but of course you choose the most convenient ones, which is the v squared over r, and therefore you just substitute, you find the answer is 8.0 meter per second squared. So what I mean by inspiring is, if you check the answer here, you find part A and B are both calculating the acceleration, but one is 7.2, one is 8.0 meter per second squared. It is kind of counterintuitive that the answer are actually different when you are talking about the same motion. But here, what the question, I mean the author of the publisher, want to tell you is that the ideas of centripetal acceleration is talking about in that instant. In that instant, what is the acceleration is, instead of the average acceleration, like here from A to B. Of course, the average is more like at the middle, but this is not the way we calculate it. In more exaggerated way, you can think about, if this at the top is C, then the velocity will be the opposite of V8 basically. So in that case, if you try to calculate the change of acceleration, it could be a different thing as well. And therefore, we are not going to use this way to calculate the average acceleration to calculate the centripetal acceleration. And that's also why it's important to use the idea from Isaac Newton. If you learn about calculus, differentiation, integration, you know that from the first principle, you know it requires you to use a concept of limit of delta t tends to be 0. So this is a very important idea actually, but of course in physics we don't require you to truly know about it, but I think it's good to appreciate the idea of this behind. For this question is pretty straightforward. So firstly, if you look at the question, it wants you to find the maximum number of revolution, and therefore, well, the question also said the limit must not exceed as 5G. Then of course you have to, since we talk about maximum number, then of course the more force experience, the better and the faster, and therefore you will take 5G for, of course. Otherwise, no, there's no other way you can do it. Therefore, since it said g is 10 meters per second squared, then you find 50 meters per second squared for the maximum acceleration. I chose the equation which is a bit stupid. You will know why. That is r omega squared. Then you substitute, I substitute all the things I know. I find the maximum omega to be this, and I use another equation relating to the frequency, which is the maximum, of course. Try to do it like what I did if you use this equation, so that the presentation is much better. So at last I find out in hertz that will be 0.357, and since the question asks per minute, therefore you need to times 60, because hertz means how many in 1 second, and which is 21.4 RPM, revolution per minute. And if you are smart enough, smarter than me, then you'll be using this equation at the first place, which can tell you the frequency directly and calculate the answers much quicker. This question is a good practice for you. So let's start. The first one is that the question is set is frictionless table, and therefore when you formulate the equation F equals ma, on the side of net force, you only need to include the tension only, but not anything else, because there's no friction. And therefore, converting A centripetal acceleration to v squared over r here, you can substitute all the things you know. You'll find the tension as 10 Newton in that case. For part B, it said the string will break at 20 Newton and determine the largest speed. And of course, in that case, you are going to set the limit as 20 Newton. And therefore, I wrote tension mass, and therefore the V will be mass as well. So the word mass and here and also here is pretty important in terms of presentation. So please do it as well. And then you just substitute all the things, and you find the velocity is 2.83 for the maximum speed. And here, of course, we assume the radius is still the same. Because in part C, now is set, since the braking tension is 20 Newton, but now you want to attain the mass to a certain speed, which is much greater as 4 meters per second. Which is of course greater than what you calculate in part B. Therefore, the only trade-off has to be the radius, and therefore you are going to calculate the new radius in that case, which is the minimum required radius. Well, the equation is basically the same, but I think it's good to practice by yourself to see how the relationship is. So it's not just one-to-one, but actually all three variables, they interrelate to each other. Anyway, later on, if you substitute all the things here, you will find the radius as 0.8 meter. So that means the radius has to be longer than the previous. Therefore, so you can go faster with the same amount of force. This question is also quite interesting here. That it said if you are on Earth, well, this is the Earth, and you're on the equator, free falling. So that means on your body there's only the weight, which is mg here, and there's no reaction force. That means reaction force is 0 here. That means basically you are free falling on the equator, and you keep moving in a circular motion of around the equator of the Earth. Then what will happen to your period? That means how much time you need to complete one circle in that case. So by calculation itself, you would say acceleration equal to g, or you may say F equals ma, which mg equal ma, which leads the same thing, g equal 8. And therefore a is, well, we'll be using this equation because it tells you the period. You substitute all the things you know. However, there's one thing that you don't know is about the radius, which is the radius of the Earth, of course. And therefore, you need to go on Google. Unfortunately, I don't understand why the question from the textbook don't provide to you. I use this one, 6371 km. I think the textbook used another one, so my answer with the answer key is slightly different, but the idea is the same. And at last, you should be able to find the period for completing one circle is 84 minutes. That's it. Next question is extremely interesting, I would say. It says there's a neutron star with certain radius and the rotational speed is extremely high, which is 25 millisecond per one revolution. So it's extremely fast if you try to imagine that. So for part A, it asks you the centripetal acceleration A, and therefore since you got R and T, the best equation is this one. And you just substitute all the things you know, you find the answer. And pay attention that, of course, for the time, it will be 25 over 1000 since it's in milliseconds. And therefore, the acceleration is so great in value. The best part is part B. If it asks you whether or not you can actually stay on this neutron star. So the idea is you have to be very clear about how the free body diagram looks like, well, which is just having the mg over here pointing downward, and also the reaction force pointing upward. And of course, in the case of having the mg larger than Fn, which would be good, so that you can perform, I mean, it has to be greater than Fn, and therefore you can perform the circular motion. But the thing is whether or not the Fn will be greater than 0 or not. So if it is not greater than 0, or what it means is if it is less than 0, then or equal to 0, then in that case your feet is actually not touching on the ground in that case. So what you're going to do is you formulate the equation F equals ma, which is net force, and therefore for centripetal force it will be mg minus the Fn reaction force equal to the ma over here. And after that, you just calculate what you have here. Since it said the acceleration of the free fall from the question is 8.0 times 10 to the power 10, then you can substitute all the things you have. And after that, you got the answer, which is 76.8 times the mass, although you don't know the mass, but since mass must be positive, and therefore the normal force must be greater than 0 in that case. And therefore, since it's positive, the arrow here must point upward. So then, of course, you are staying on the surface of the star in that case. Okay, next question is also very interesting as well. So firstly, you're going to draw this picture, Earth and the Sun with the radius over here. And for part A, it asks you the orbital speed. So what you're going to do is, orbital speed is just the linear speed, the same thing. So therefore, you use the equation here because from the question, you got the radius, r, and for the period time t, you should surely know that, because for the Earth to surround the go a circle of the around the Sun, it will be 1 year, right? So it will be 60 times 60 times 24 and times 365 days for a year. And therefore, you can find the velocity as 3 times 10 to the power 4 meters per second. For part B, it asks you the centripetal acceleration experienced by the Earth, and therefore you look for the centripetal acceleration equation. There are 4 that I mentioned. If you are not familiar enough, then go for it and have a look. But then eventually you still choose. I think the best is the first one, v squared over r, because you got v from part A and r that's from the question as well. And therefore you find this is the acceleration, centripetal acceleration for the Earth. For part C, it asks you from that you determined the magnitude of gravitational force, that means weight, exert on the sun by the earth. So here is a one thing that it kind of requires you to understand the Newton's third law here. If you remember Newton's third law, it said the forces always exist in the same magnitude but opposite direction. So in this case, the gravitational force exert on sun is the same as the gravitational force exert on the earth as well. And since you know that the earth, the way that it moves around the sun is due to the weight attracted to the sun as well. Therefore, this is actually, the weight here is actually acting on the earth. But since we know about Newton's third law, then the whole thing is legit. And therefore, what you're gonna do is just use the mass of the earth. You don't need the mass of the sun. And by using the centripetal acceleration you calculated previously, and that would be the gravitational force on the earth and also on the sun as well by each other. Next question is an extremely common question, typical question about banking angle. So right here is a plane, and this is more like a back view. And what I'm going to do is I need to analyze the question more carefully. I draw some more pictures here because I'm going to decompose the lift L here with the angle, and therefore obviously the one from the question is not very good. Therefore I need to determine this is also theta, and this is 90 degree minus theta. I'm sure you understand why, because this is right angle here. After that, what you're gonna do is to write the formula that you know. So and also the picture. So this is a picture of how you are going to decompose the lift L with the angle 90 degree minus theta here, and obviously this is sine, this is cosine. I think this is the best way to do when you see a diagonal vector, and the one is sine, opposite is sine, the one under it is cosine. After that, you are going to formulate two equations because for the plane itself, it has weight, of course, and therefore the one that is go vertically, which is this one, it will be compensated to the weight mg, and therefore this is the first equation. The second equation, which is for the horizontal component of the lift, which is a cosine one, will be responsible for the circular motion, and that's how you formulate the equation. And since you know in maths you learn about this equation, right? And therefore that's why I make it more simple by converting it back to cosine theta and sine theta. After that, the best things you do by these two equations is you can combine them. So if you remember, sine theta over cosine theta in your maths equal to tangent, and therefore you can, in this case, the best thing is you can cancel out the m in this case, and therefore you find tangent theta equal to this v squared over rg. By substituting all the things from the question, theta equals to 35 degree for the speed, and also for the g, which is 10. Oops, I should use 9.81, but anyway, that's the idea itself. Later on, you'll find the radius as 4.6 times 10 to the power 3. And what it means, more importantly, from this practice is you can see that in this case, this is the most important equation that you kind of derive by yourself. And this, the best thing is it does not, it's not dependent on the lift and also the mass. So when you are doing a turn in a plane. For the next question, it's pretty good to practice with this because you have seen the question, the video in the lesson I showed you. If you remember, this machine is going to turn, and the people inside does not need to touch the ground, and their back will be kind of like stick to the wall in that case. So pretty interesting here. For part A, it needs you to calculate, not calculate, but draw the free body diagram. So right here, of course, for a body has weight, and also obviously you know there is normal force so that it can maintain the circular motion. And for the friction here, since the person is about to slip downward, and therefore the friction must be pointing upward to counteract the weight in this case, and it should be pointing absolutely upward, because for the normal force should be fully responsible for the circular motion in that case. Then for part B, what you're gonna do is you're going to calculate the minimum amount of revolution per minute so that it can keep them up in the wall. And pretty obvious that if you don't turn fast enough, the person cannot be sticking on the wall. Instead, they will fall down, and of course that will be not successful in that case. So the first thing you're gonna do to be more organized physics student, then you'll be doing writing down all the equation that is related. So for the first one is considering the friction itself. Like what I said, friction must be smaller or equal to the maximum, which is coefficient of friction, times the normal force. So remember the relationship that you learned previously. The greater normal force you have, the greater friction you will have in the surface. Second one is about the friction equal to the weight. Since we have already drawn the free body diagram here, like we said, since it's not slipping, then it has to be the same. And lastly, about the normal force, which will be relevant to the circular motion, then I'll just write this equation here. After that, what you're gonna do is basically combine all these three equations, and therefore you will find that the m can actually cancel out on both sides. And after that, you just substitute all the things you find, and then you find the omega here, which is 1.8 radian per second. And therefore you can calculate from that, since radian means how much radian per second, therefore you are going to change finding how much revolution, that means how many circles, complete circle that you can complete in minutes. So for changing radian to revolution, then you have to use 2 pi, right? Because I'm pretty sure you know how you convert radian to circle, and then you have to times 60 because it's in minute, and therefore it's 17 revolution per minute. Next question is very typical and but also pretty easy question to do. It said there's a trolley, a car moving upward the loop, and then make sure it won't fall at this point, and then complete the circle and go back down here. The first one it asks you is the minimum speed which the car must enter the loop at the first place over here. And then the second question is about predict the speed at the top. However, I don't know why they set up the question like that. For me, myself, I would actually calculate the minimum speed, the speed at the top first, so that you can lazy find out how much speed you need before you enter the loop. Anyway, for the free body diagram here, you can see that both force, weight, and also normal force, since it's 90 degree, are pointing downward. In that case, using F equals ma, net force will be weight plus normal force here. However, since in this case you want to find the minimum speed, and therefore it's like almost falling. What it means is your feeling will be like weightless, and therefore the normal force will be 0. And of course, this is the way so that you can obtain the smallest v here, and therefore the speed at the top, which is the answer for part B, will be 13 meters per second. So for going back to part A, in order to calculate 13, then you consider the conservation of energy. I assume here, of course, it is frictionless in this question, and therefore you can use the energy at the top, which only has the KE and of course the GPE that you gain, to the ground, which is the KE, and you substitute all the things, you find out the velocity on the ground is 30 meters per second, which requires so that you can get 13 at the top, and complete the whole loop without falling. The next question is a very usual setup for the lab. You can see that from the question it said there's a string with the bigger mass mg, capital letter M, and then tension along the string, of course. Then obviously tension here, because of this, equal to the capital letter mg, and while this one the tension will be used for the small mass for the circular motion over here. And after that, you combine the two equations, you find out the velocity will be relying on this. And well, that's the answer, because they don't tell you any figures. Next question requires you quite a lot of organizational skills and also the trigonometry as well. So you have to be very patient and very careful in writing the sentences at the beginning. So first of all, when you analyze a question, you should see that this is a mass and this is a velocity, that it keeps rotating. Tension, obviously tension 1 and 2 here, they are different. They have to be different, because if you think about the condition, they are having relationship with the other things, which is for the ball, it has the mg, and also the horizontal component will be used for circular motion. So in that case, what you're going to do is you're going to draw this triangle, so that you can find that the angle, which is 30 here, so that you can do the decomposition of the vector t1 and t2. And also you want to know the radius r, because you know the ball is rotating here, and therefore by trigonometry itself is you find is cosine 30 degree. After that, what you're gonna do is you're going to write down the relationship of t1 and 2. So vertically speaking, then think about for t1, what it will do is it will going up. In that case, for the vertical component for t1, and for t2 it's going down, and also of course for mg it will go down as well. And of course the ball is doing circular motion on the same level, and therefore that's the relationship you find. And horizontally, all the forces which horizontal component from the tangent t1 and 2, which is the cosine here, will be used altogether for the centripetal acceleration over here, and that's the equation you generate. And since you got two unknown t1 and t2 and two equations, you should be able to solve this question by algebra. So if you want to know more, then what I say I could do is converting equation 1 by t1 as the main term, and then substitute the whole thing. Equation 3, I call it into 2, and this is a whole thing of t1 that you can see here, which is pretty long, I know, and then the rest are the same basically. And then you will find the other things from the questions, and also the r, we said that is 1 times cosine 30. After the tedious algebra, I can't show it because there's no space, and I don't think it's meaningful to go through it step by step with you. You'll find the answers t2 as 8.2 Newton, and using this answer you can substitute back to any equation at the top. You'll find t1 as well. For the next question, I hate this question because it wastes me so much time on understanding this, because it's nonsense. And when I look at the suggested solution from the publisher, it's also a bit nonsense as well, and it takes me time to get the question understand. Actually, I actually is guessing the question from backward from the answer itself. So what happened here is just listen to me, you can forget about these things. So basically this is a car, and well, this is the mass which are correct. Actually you only need 60 kg for one passenger. And what happened next is this is actually not A. So what you're gonna do is take A at the point where it almost start the loop, and at the lowest point here, and the H is really 120 meter, and also the radius is really 30 meters as well. However, for the last sentence, what I don't know what it says is a strict stretch from A to C where friction blah 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 is 40 meter. So forget about this. This is completely trash. Forget about this. It's unclear. So what you're gonna do is before you start to do this question, you can assume that this path until you complete the loop over here, these are frictionless, like the question said. And after that, you can imagine that it enters, a track which would break the car down for 40 meters. So and therefore, when you are calculating the first part of the question, forget about the friction, and after that for part C, you'll be using you'll be considering in this case. So you may now truly do your question. Okay, so finally we can start to talk about this question. So part A, since we assume it dropped from 0, so initial velocity is 0. I mean, when you say drop, it has to be 0. And then the GP it has will turn into KE for all of them without any friction, and then therefore there's no work done, and therefore if you substitute all the things you know, you find the velocity is this one. For part B, it asks you the reaction of the reaction force acting on the passengers at the top. That means point B. Then that is how it looks like. So the weight and also the reaction force, they are both pointing downward at B, and therefore you have the equation R plus mg equal to the centripetal acceleration times mass. However, in this question, in this equation, you don't have V, and therefore you must find V first in order to find the R. By using the conservation of energy without friction, remember, and therefore we can use the GPE at first equal to the GPE at that moment plus the KE. Since the radius is 30, so 30 times 2, and KE is the one related to the velocity, which at last you find is 34.3. And finally, you can use the equation R plus mg, this one, with the circular motion into the substitute in the equation with the V. So this is a V squared. And after that, you will find the normal reaction to be 1,700 something. For this one is actually I would expect you to have will give it more meaning and feeling on it, because think about that. For a normal person which has 60 kg of mass, then normally when that guy or woman standing on the ground, well, he or she will experience 600 Newton of force, which means normally 1g. So in this case, since the reaction force to that person is 1,700 something, so you can try to think about this: reaction force equals to mass times acceleration in that case. So that's the acceleration that he or she experienced. Not exactly, but the feeling itself. So the acceleration, or you may use the word g instead, that person experience in this case will be 1765 equal to 60 times g. So the g that it experienced should be roughly, let me calculate, should be roughly 29 meter per second square. So since you know 1g on Earth is roughly 10, so this normal force will be more like 3g kind of g force. So well, it's not the mobile phone 3g. It's talking about the g force that you experience is more like a triple of the normal one. So that means if you're like a person standing on the ground, then it's like you are having two more person, I mean two more yourself standing on top of you, and of course you feel the gravity is much greater. It's a triple. Anyway, for part C, what it wants you to do is set the acceleration experience when it's braking, so from A to C. And therefore, since before you start to brake, there's no friction, and therefore velocity for leaving the loop is the same as entering the loop, which is part A. We calculated 48.5, and using that with the kinematic equation, this one, you can find the acceleration with the distance 40 from the question itself. Therefore, you find the acceleration will be 29.4. For this one, the meaning itself is very similar to what we have here. However, for this one, you can clearly see that now the G is again very similar to the 3G, the normal 3G. So this one is a bit different from the one we mentioned here. This one is more like a horizontal one, horizontal G-force. So yeah, there are different axes. That's the end of the video. Thanks for watching. Peace.